Welcome to Nano Industrial Excellence. So today I would like to share on very important topics about the line balancing. So if you see the video from beginning to end, so it will be like Aladdin's lamp. So before going to today's agenda, I want to share my experience in brief. Once upon a time, I was recruited as a industrial engineer on of the reputed group in Bangladesh. So their version is like that if they recruit the I guys, then production will go automatically is very up like the magic of Aladdin's. But actually it doesn't. Finally, I was also disappointed. So how we can make the right improvement? So currently, who is working in the industry engineering department or who is planning to build up your career in industrial engineering department? So definitely you have to learn the balancing techniques. So first 2-3 minutes I'll work on the theoretical part and I'll go to the practical sessions. So let's stay with us. So here, if you see the imbalancing percentage here, so like for the line one, if you give the input 100 pieces per line, since here is capacity is 100 pieces, but here is capacity 50 pieces, second operations. So you will get the output of 50 pieces per line or per hour. Or as a second line, if input 100 pieces per line, then also output is 50 pieces per hour or per line or per hour. So that is the imbalance. It's 50% imbalance. So what would be the standard balancing percentage? The reason for the imbalance is lack of knowledge for balancing. A lot of people does not know. During the operation bulletin or during the making the layout, they are not much aware on the balancing percentage. No proper standards, so there is no standards. Operator time standards are very widely. Operators are not deeply analyzed by motions. Time standard inaccurate. Operators are not skilled enough. Operator space is not equal all the areas. So balance. Balance means equal work distribution among all the resources. So definitely we have to learn how we can make the balances. So I'm just going in brief the balancing steps, collect the process steps with all that with the time, identify independent operations, and calculate the piece time. Piece time is total assembly or total cycle set time divided number of operators. Group the operations into a small group where you cannot balance the operation nearly to the piece time. If balancing loss is more than 10%, again start from the beginning. Break the operations into motions and evaluate what motions can be delivered into previous operators or next operator where it is possible. Draw the machine layout to minimize the operator handling and transportation time. Define the maximum and minimum WFA in the orchestrations. So that basic cases you have to follow. So who is doing the industry engineering department? You don't have any magic. You have to use or utilize your head or brain before releasing the operation layout or operation breakdown. So let's see in the Excel grid once you are making the or you have already done the operation bulletin. See here the Excel grid. Then I'll go to some video wise software based video balancing. So I'm going to the Excel based balancing. So here I'll not go the details, that I'll give the one example here. Like you have made the sequence as per sequence the operation breakdown, what is currently running in the your production line. So easily you can see how much imbalance of that particular line. So suppose this is overlock at front 4 parts. So that is on the front parts overlock, the 4 part they are doing the one part of doing the overlock machine, and the cycle time was 0.29 by giving the allowances. So here the allocated operator is 2 and dedicated cycle time then divided 0.29 divided 2 equal to 0.15. This should be 0.15 time. So accordingly capacity per hour is coming 412 pieces. So every day you are getting the output or per hour is 320 pieces. So here the hot time he was or she was wasting during this process. So if you see here capacity per hour minus what are the possible output per that line, multiply what are the cycle time for this process. So here 26.7 minute time minute lost per hour. That means two operator. If you consider the one operator, he or she is working 1 hour, and second operator he is working only 50% time. That means around 30 minutes or 33.7 minutes he was utilizing his time. I'm going one more example here. This stack at level. If you see here, stack at level. So there is a single little locations machine. Here cycle time is 0.15. Operator allocated for one operator. So again, then I have divided here the total cycle time divided 1 equal dedicated cycle time for the line is 0.15. The capacity per hour again is 400 and possible output again 320 pieces. So if you look after this one, the time minutes lost per hour, then 1 hour how many minutes that operator are sitting idle. So 400 minus 322 into 0.15, that means 12 minutes is coming. So she or he was wasting 12 minutes per hour. So that means he was working 48 minutes and 12 minutes is idle. If you look up to the imbalancing graph here, 22% of the imbalance and balancing of 78%. So if you look up to the graph here also, so that is also the wastage percentage as per the process, how many minutes they are wasting per hour. You can see this one. So that was 78% balance. If the line balancing, so before releasing the operation bulletin, you have to make the wastage percentage or imbalance calculation. How much percentage it's imbalance as per your cycle check time or PMTS or GSDSMB or time study. So before releasing this, so you have to calculate okay, how much before releasing the line or operation bulletin, how much balance is there. If you do the only balancing percent 78%, then question easily arises, what would be the efficiency percentage? If they work only the 78%, then efficiency will come only 45 to 50%. So that you have to focus before releasing the line. Now I am going to another part that is for the software based video balancing. So a lot of people, so you are wasting your time by doing some Excel based analysis. So you can make it some VBMAC, some Excel based, some logical formula you can give, so you can use, you can develop some software based basically balancing software, so that also you give the input, give some of the, you can select based on the operator, and you can make some analysis very quickly, and you can give the some right decisions. So let's look after the software based balancing. I told you, please look after the video carefully from beginning to end. Then it will be very easy for you to work in industry engineering department, and as well as you can contribute in your country, and as well as change the other countries' efficiency. So here you can balance by operator or by piece. So if you already select the style, then what would be the balance to minimum operator, out of the maximum operator, out of the efficiency percentage. So what is the bottleneck capacity? Then automatically it will come the bottleneck capacity. How much SMB was there, how many manpower required, what are the allocated manpower, what are the hourly target, what are the takt time, what is the balancing percentage here. Yes. So like this way, uh, you can make the line layout. If it is we want to shift the, okay, what is the more standard range for the operator, what is the minimum operator or the maximum operator, or else you can do by piece rate. Okay, per day I need this much amount, or per hour this much amount. So you can make two options. Then what would be the standard balancing percentage? So if you follow this methodology, and make some like video based or Excel based software, then easily you can achieve your goal and target. So please let me know, do you have any questions or any support required uh, to make the effective line balancing, who is planning to work in future in the industry engineering department, or who else is working in current department, and how you can make easily the right efficiency as well as in the one-time shipment. So thank you for watching this video.